Okay, welcome back. This is Lesson 4 in Module 1 for Contemporary Mathematics. We're going to continue our look at the nature of solutions of a system of linear equations. So we learned that there's 3 different options for a system of linear equations. Okay, we can have 1 solution, 0 solutions, or infinite solutions. That we learned that in the last lesson. Okay, and it all has to do with the different results that we get when we go about solving the system. We also learned and reviewed another method of solving a system, and that is using substitution. Okay, the substitution method involves taking one of the equations that's already solved for a variable and substituting it in for that same variable in the other equation. Okay, so here, for example, this bottom equation was x equals y plus 5, and so where we had that x in the first equation, we replaced it with the y plus 5. Okay? And then solve from there. So let's do that some more here with some more practice. Okay, in this situation right here, you'll look at both of those equations, and neither of them are solved for a variable, but we can fix that, right? So let's take this bottom equation here. It's got some pretty, small numbers and stuff, and we'll pick one of the variables to solve for. Let's solve for x, and so in other words, we're going to get the x by itself here by adding y to both sides, and so we'll have x equals 5 plus y. Now that we have this, anytime we see an x, we can substitute in a 5 plus y, and we'll do that up here in this equation. So this will become 7 parentheses 5 plus y plus 2y equals negative 4. And we'll just distribute. So 7 times 5 is 35. 7 times y is 7y. Still have the plus 2y, and that equals negative 4. And we'll subtract the 35 from both sides over to this side. 7 plus 2y we can also combine together and make that a 9y. And then negative 4 minus 35 is negative 39. Okay. We'll then divide both sides by 9. Oof, and we're going to get a yucky number here. So, let's see here. 5 plus y. 7 times 5 plus y is 35 plus 7y plus 2y equals negative 4. 9y, 35. Yeah, that's right. Okay, so that's pretty yucky. Okay, so you'll notice here, though, that it just says to determine the nature of the solution to each system. So in other words, it doesn't say to come up with the precise solution. It says to just come up with the nature. So that means we just need to identify, is it 1, is it 0, or is it infinite solutions? Well, here we can see that we got y equals negative 39 over 9, which indicates a single y coordinate, which we will then be able to plug back into like that y coordinate right there and solve for x. And so it's going to give us one answer. So this is a one solution situation here. Okay, remember for the no solution, we ended up with a impossible equation. Let's take a look at this next one and see what our result is. Okay, in this one also, we don't really have any super nice, easy ways to solve here. So I'll just pick this bottom one, and I'll solve it for y. And then we'll plug into that top equation for the y. So we'll take 3x plus 2y. We'll subtract 3x from both sides. We'll end with 2y equals 1 minus 3x. Divide everything by 2. And there's our y that we have now. So anywhere I see a y, I can plug in this 1/2 minus 3/2 x. So up here, where we have a y, I'll replace that y. In fact, maybe I'll do it this way. That y will put in the 1/2 minus 3 over 2x. Like that. Okay, and then we'll simplify by distributing. 6 times 1/2 is 3. 6 times 3/2 is going to be minus 9. Okay, 9x and minus 9x cancel, and we have 3 equals 3. Now, this looks pretty similar to the first problem that we did, but there's a difference. Was this equation true? No, it's never true, right? So there was no solution. In this case, though, this is always true. 3 always equals 3. So what does that mean? It means infinite solutions. these two equations, okay, are the exact same. If you divide this top equation here, if you divide both sides by 3, you end up with the exact same as the second equation. They're the same line when you graph them, so they'll be infinite solutions. All right? Next one. Determine the nature of the solution to each system of linear equations, and if it has a solution, find it and verify your solution by correct graphing. All right, well, I'm not going to worry about graphing because they didn't really give us graph paper here to use. But you can use a graphing calculator to check that or something like that, or maybe a graphing tool like Desmos. Okay, you can type these in to Desmos and graph them. Okay, so for this one, again, let's use substitution here. So none of these equations are solved for a variable. So I'll just pick this bottom equation here, and I'll solve it for x this time. So to get solved for x, I'm going to subtract y from both sides. Okay, and then we will substitute in that negative 7 minus y. We'll plug it in for this x right here. Because again, this is saying x is this. Right? These are the same things. So in the other equation, I can replace that x with exactly this. And I'll use the blue again. So distribute. Whoops, I can't read my own handwriting here. Negative 3 times minus y is minus 3y. Plus 3y equals negative 21. Okay, and look at that. The 3y's cancel. We have negative 21 equals negative 21. In other words, what kind of solution do we have here? 1, none, or infinitely many? We have infinite. Because we end up with this equation, that's always true. Okay, so let's see here. All right, maybe we'll do 2 more here, or we'll do 1 more video, after this one. So thanks, guys. See you next video.